Okay, in this video, we are going to see how to set up your PYNQ Z2 board from the scratch. First, you need to download the PYNQ Z2 image. That is, you can search for pynq.io, then go for boards. Now, like we are doing it for the PYNQ Z2 board. So you need to download SD card image of version 3.1. Once you have downloaded, this image has to be H and you have to write it in SD card. Okay, so you are supposed to have a SD card of document says like 8 GB, but when I have tried with 8 GB did not work. So you better try it with 16 GB SD card. So at this point of time, you are supposed to have a SD card that is inserted in your laptop. Now, for the image etcher, you can use a Balena etcher. So you search for etcher.balena.io and download this application. Okay, so now we are going to see how you can flash. So go for the Balena etcher. Yeah, here you need to select the image file, that is .img file, which you have downloaded just now. Select, which is this one, and your target as your SD card. Here I am using 256 GB because I am having that. Select, then flash it. Yes, yes, I am sure. Then it will start to flash. Okay, so this is PYNQ Z2 board. This is the main chip. It consists of processing system and processing logic. And you can see all other peripherals. Here are audio peripherals used for any audio projects. Similarly, you can have HDMI projects. Here, there are Raspberry Pi and Arduino Uno headers. You can see here one there is Ethernet port, then USB port. There is a power jack. Here there are 4 push buttons. Basically, these are used as inputs for any basic projects, and 4 LEDs, small LEDs. Those can be taken as output for any small project for like Boolean XOR or Boolean AND projects, something like that. Now, this board can be powered in various ways using power jack, using USB, or it can also take 5 volts in from the Arduino header. So we need to tell to this board like how you want to power it. So here there is a small mode setting thing. You can have a jumper. Yeah, this is a jumper. So here you can see there are 3 pins, which is denoted by regulator and USB. So you need to tell to this board, okay, we are going to power it using USB. So you keep this jumper at top 2 pins that will indicate as USB. So I simply press this. Okay. So now to work onto this board, we need to boot it. So for booting, we need to select SD card mode. So here you can see there are 3 types actually. 3 different modes: SD card, QSPI, and JTAG. So basically JTAG is used for programming the PL section. Now first we need to boot. So I am going to select the SD card mode. So you take the jumper as same way before. Then you keep it to the left 2 most pins. Now this board is selected for the SD mode. Okay. So now yeah, this is SD card. This contains of PYNQ image. So you simply flip the board and insert it the other way. So if you push it again, it will easily come off. You can take it off. So gently press it. Okay. Now once you have done this thing, settings, you connect your USB. and connect your USB to your computer. And there is basically power switch. You need to toggle it to the on. So you need to wait for it. Immediately, red LED will come on. Then after booting, few LEDs will glow. Yes, so it has taken at least like 1.5 to 2 minutes. So now it has booted. So now you need to connect your board to the computer. So actually we are not providing any internet to the board, so we cannot install the packages for any project. We are just simply communicating with your computer. So through Ethernet, you insert Ethernet cable here. Then other end to your computer. Now just for a small check, you open your command prompt in Windows, ping to its IP address, that is 192.168.2.99. So your computer is trying to connect with the board. So like your board to connect with the laptop. So you need to switch off any VPN in the background. Now you can try again. Yeah, now your board is replying. So your computer is sending some packets of data to the board. Again, again the board is replying back with the same packets. So there is minimal loss. There is no loss at all. So now the connection has been established between your computer and board. So now you go to your browser, search for the IP address. Okay, once you have booted your board successfully, you need to establish connection between your computer and the board so that you can interact with the board. Okay, for this, I expect that you have connected your Ethernet cable between your computer and the board. However, we are not providing internet connection to the board, as we are just connected with the Ethernet wire between the computer and the board. Okay, you go to control panel, then you go to network and internet, network and sharing center, change adapter settings. Here you can see two options for the Ethernet, Ethernet 1 and Ethernet 2. You need to choose Ethernet with Realtek PCLE GB family controller. So go for it. Then go for the properties. Here for IPv4. Okay. Then properties. Select. Now your board is having local IP address of 192.168.2.99. So you need to set the IP address of your computer like 192.168.2.0 to 255, any number between 0 to 255. So I have set the IP address of my computer as 192.168.2.1. Okay, so you click OK, close. Now just to cross check whether the connection has been established between your board and the computer, let us do a small test. So you go to the command prompt, you type ping, then your board IP address, that is 192.168.2.99. That means we are trying to interact to the board through your computer. So enter. Now it is basically pinging to the board. So it will send some packets of data and the data will be transmitted back to your computer from the board. So you can see it has sent 4. Your computer has sent 4 and it has received back 4. So there is 0 loss. That means the connection has been established between your board and the computer. Okay. Now you go to now you can search for your
board IP address, that is 192.168.2.99. Okay, enter. So it will ask for the password. So your username and password both are Xilinx. Login. Yeah. So this is actually like they will give some inbuilt examples. So in the demonstration one, we can simply go for a example like a logical XOR operation, which will take two inputs and it will output and it will output. So when there is like 0 0, it will output 0. When it is 0 1, it will output 1. When it is 1 0, it will output 1. When it is 1 1, it will output the 0. So basically, if there are two different types of input, then it will then logic will be high. So you go to logic tools, go for the Boolean generator. So this is actually inbuilt example. Yeah, it is taking some time to loading. Yeah, so this is basically a Jupyter notebook, which will have cell. In cells you will write the part of the code and then you will run. Okay, so you can run this like control enter or shift enter, or you can also use this tab. Yeah, here you can see this example is of two input XOR operation. So you can see LD2, that is LED2 on the board. Yeah, like you need to see the board to see the markings, equal to push button 3 XOR with push button 0. So on the board you will have this push buttons. So this is the function you have defined. Then you set up. Yeah, you can see here this is push button 3 and this is push button 0. So basically these two PB3 and PB0 will work as input and the output is LD2. So when you press any one of the button, this LD2 will glow. That is, any one of the input as 1, then it will glow. So the you run that function basically. So after this running, you can test. So on your board, you can actually press any one of the button and it will glow. Now, once you want to stop the function, you can stop it. Now, if you run, it won't work. Okay. So this is all cells in a combine as a single cell. You can run, then you can play with your board, then you can stop. Yeah, this is one of the example.
You can see in this example, I have defined push button 3 and push button 0 as input and LD2 as output for the function of two input XOR. So now you see these both inputs are in 0 state. So there is no output. The output is logic 0. So once if I press any of the push button or any of the input is high, your output will be logic high. If both of them are high, then also your logic will be low. So this is
Similarly, we can go for the like other example, MNIST. So here for as we have not provided internet to the board, you cannot install any packages basically. So what I have done is like you can run your training on your laptop. Basically you can use your Jupyter notebook, not this one, other one, or Google Colab. Then you note down the weights .npz files, then you can upload here and you can run those things actually. So uh, yeah, you go to the home page. Here you can upload the files. So you upload what? So I have trained the weights, that is MNIST weights, and also the MNIST test offline. So this is small part of data so that I can test it on board. That is basically inference. So you choose them and upload it here. Now you need to run the inference code. So basically, you need to start a new notebook. So you go for the new Python 3 kernel. Yeah, basically this is for the inference. So you run it. Yeah. So the after inference, you can see the accuracy and how much time it has taken for the inference, CPU usage during the inference, and the memory used. So this is the demonstration 2 for the inference of MNIST. Likewise, you can implement the other project